Hi everybody, I am Muhammad Taqiyuddin MT, Postgraduate Department of Mathematics, E-Content Development Center, Majlis Arts and Science College, Paramanur. Today we are discussing number theory. It is a branch of mathematics. Now we are discussing introduction to number theory. What is number theory? Here we are discussing divisibility, prime and composite numbers, modular operation, congruence relations. This is the outline of today's class and readings. Introduction to number theory by Tom M. Apostel. First we are discussing divisibility. What is divisibility? Definition: given integers a and b. Here a and b are two integers with a not equal to 0. Then a divides b. That means a divisible by b. A divides b means a divisible by b. If there exists integer k such that b equal to ak, that means b is the multiple of a. b equal to a means b is the multiple of a. Here k is constant. Then a is called a divisor of b and b is a multiple of a. A is divisor and b is multiple. Proposition: if a not equal to 0, then a divisible by 0 and a divisible by a. Choose any number. 5 is a number. Choose a equal to 5. A not equal to 0, that means 5 not equal to 0. Here we know that 5 is divisible by 0. That means 0 by 5 is possible, and 5 is divisible by 5. That means 5 by 5, that equal to 1. That is possible. Also 1 divisible by b for every b. That means every number, that is every number b means 1 divisible by b. And next proposition: if a divisible by b and b divisible by c, then a divisible by c. A divisible by b, b divisible by c, then a divisible by c. And third one is: if a divisible by b and a divisible by c, then a divisible by sb plus tc. That means a divisible by multiple of b plus multiple of c for all integers s and t. Okay. Next, prime and composite numbers. Prime and composite numbers. Firstly, we are discussing prime number. What is prime number? If an integer n, that is greater than 1, an integer n greater than 1, therefore an integer n greater than 1 is called a prime number if its positive divisors are 1 and n. Its positive divisors are 1 and n. That means if we choose a number n, then it has two divisors that are 1 and n, and all other numbers are not divisors. Okay. Next definition: any integer n greater than 1 that is not prime is called composite number. If an integer is not prime, then it is called composite number. Example: prime numbers 2, 3, 5, 7, 11, 13, 17, etc. all are prime numbers. We know that. Choose 11. 11 has two divisors, 1 and 11. Okay. And another number 17. 17 has two divisors, 1 and 17. Composite numbers 4, 6, 25, etc. Here 25 has so many divisors. You know that 1 is a divisor of 25, 5 is a divisor of 25, 25 is also a divisor of 25. Therefore 25 has more divisors other than 1 and 25. Okay. Next, decomposition in product of primes. Theorem: fundamental theorem of arithmetic. Any integer n greater than 1 can be written as a product of prime numbers greater than 1, and the product is unique if the numbers are written in increasing order. That means n equal to p1 raised to e1, p2 raised to e2, etc., pk raised to ek. Here p1, p2, p3, etc., all are prime numbers. Here example 84. 84 means 2 square into 3 into 7. If we choose any composite number, another example 18 is composite number. Okay, firstly we divide 18 by 2, then we get 9. Okay, after that we divide 9 by 3, that we get 3. Therefore 18 equal to 2 into 3 square. Okay, in similar manner 84 equal to 2 square into 3 into 7. Next, modulo operation. Definition: a mod n that equal to r implies there exists q such that a equal to qn plus r. A equal to qn plus r. That means a is the number is multiple of q plus r. R means the remainder. A mod n equal to a equal to qn plus r. Here 0 less than or equal to r, less than or equal to n minus 1. Choose any number. We choose 11. 11 is prime. We know that 11 is prime. 11 divided by 5. That means 11 equal to 2 into 5 plus 1. 11 equal to 2 into 5 plus 1. Here 1 is the remainder, 5 is n, and q is the multiple of n. That equal to 2. That means 11 equal to 2 into 5 plus 1. Another example 7 mod 3, that equal to 1. 7 mod 3, that equal to 1. That means if we divide 7 by 3, 7 by 3, then the remainder is 1. Also minus 7 mod 3, that equal to 2. We divide minus 7 by 3. You know that minus 7 plus 2, minus 7 minus 2, minus 7 minus 2, that equal to minus 9. Here 7 minus 1, 7 minus 1, that equal to 6 is divisible by 3. That means 6 divides 3. And minus 7 mod 3, that equal to 2 means minus 7 minus 2, that equal to minus 9. That is also divides 3. Then next, congruence relation. Congruence relation. Definition: let a, b, n be integers. A, b, n be integers with n greater than 0. We say that a congruent to b mod n. A congruent to b mod n if a minus b is a multiple of n. A minus b is a multiple of n. We choose any number. 11. 11 congruent to 1 mod 5. 11 congruent to 1 mod 5. That means 11 minus 1, that equal to 10. 11 minus 1 is a multiple of n. Okay, 11 minus 1, that equal to 10 is a multiple of 5. Choose another number. 21. 21. You know that 21 congruent to 1 mod 5. 21 congruent to 1 mod 5. That means 21 minus 1, that equal to 20 is divides 5. Next, properties. First property says that if a congruent to b mod n, if a congruent to b mod n, then we know that a minus b is multiple of n. A minus b is multiple of n. If and only if the first step say that n divisible by a minus b. N divisible by a minus b. Second step says that n divisible by b minus a. N divisible by b minus a. Third step says that a equal to bk into n. A equal to b plus k into n. That means a equal to b plus multiple of n. And another step, b equal to a plus k into n. B equal to a plus k into n. That means b is equal to a plus multiple of n for some integer k. Example 32. Choose any number. 32. 32 means 32 congruent to 7 mod 5. 32 congruent to 7 mod 5. That means 32 minus 7. You know that 32 minus 7, that equal to 25. 25 is multiple of 5. Okay. Therefore, it says that 32 congruent to 7 mod 5. Next example, minus 12 congruent to 37 mod 7. Minus 12 congruent to 37 mod 7. That means minus 12 minus 37. Minus 12 minus 37. That equal to minus 12 minus 37. That equal to 49. Minus 49. Minus 12 minus 37. That equal to minus 49. You know that 7 is a multiple of minus 49. 7 is a multiple of minus 49. Another example, 17 congruent to 17 mod 13. That means 17 minus 17. What is 17 minus 17? That equals 0. 0. 17 minus 17, that equals 0. 0 is a multiple of 13. Okay. Next, properties of the congruence relation. Properties. First property. First, let a, b, c and b integers with n greater than 0. We choose for numbers a, b, c and n. First step, a congruent to 0 mod n if and only if n divisible by a. A congruent to 0 mod n if and only if n divisible by a. Second step, a congruent to a mod n. A congruent to a mod n. Then that means a minus a is multiple of n. Next, a congruent to b mod n. That means a minus b. A minus b. That equal to a congruent to b mod n. Then a minus b divides n. If and only if b congruent to a mod n. A congruent to b mod n, then b congruent to a mod n. Next step says that a congruent to b and b congruent to c mod n. A congruent to b mod n, b congruent to c mod n, then a congruent to c mod n. This is the fourth step. Corollary, congruence modulo n is an equivalence relation. Next, every integer is congruent to exactly one number in 0, 1, 2, etc. n minus 1 modulo n. That means if we choose a number n, if we choose a number n, you know that 1, 2, 3, etc. n minus 1 are less than n. Okay, then there is any number lies between 0 to n minus 1. That is the remainder. That is the remainder of that number. Every integer is congruent to exactly one number in 0, 1, 2, etc. n minus 1. That means here any number 0, 1, 2, etc. n minus 1 has congruent exactly one number in this set mod n. Next, more properties. First, proportion. Choose numbers a, b, c and n. B integers with n greater than 0. First property says that a congruent to b mod n and c congruent to d mod n, then a plus c congruent to b plus d mod n. A plus c congruent to b plus c mod n. Next, a minus c congruent to b minus c mod n. And third one, a into c that congruent to b into d mod n. These are the three properties. Here example 5 congruent to 12 mod 7 and 3 congruent to minus mod 7. 5 congruent to 12 mod 7, 3 congruent to minus 4 mod n. You know that 5 congruent to 12 mod 7, that means 5 minus 12. 5 minus 12. Here 3 congruent to minus mod 7, that means 3 plus 4. 3 plus 4 equal to 7. 5 minus 12, that equal to minus 7. Here minus 7, then the remainder is 0. Here 7, then the remainder is 0. Then first step say that a plus c congruent to b plus c mod n. A plus c congruent to b plus c mod n. What is a plus b? First a plus c, 5 plus 3, that equal to 8. 5 plus 3 equal to 8. Next b plus d, that means 12 minus 4, that is also 8. Therefore a plus c congruent to b plus c mod n. Here 8 congruent to 8 mod 7. 8 congruent to 8 mod 7. Next one is a minus c. What is a minus c? 5 minus 3, that equal to 2. 12 minus 4, that equal to 12 plus 4, that equal to 16. First you get 2, second 16. You know that 16 congruent to 2 mod 7. 16 congruent to 2 mod 7. You know that 16 by 7, then the remainder is 2. Okay, therefore here the remainder is 2. Also a minus c, that equal to 5 minus 3, also 2. This is the second stage. A third stage is a into c congruent to b into d mod n. AC congruent to b d mod n. AC means 5 into 3, that equal to 15. 5 into 3, that equal to 15. Next 12 into minus 4, that equal to minus 48. 12 into minus 4, that equal to minus 48. Then the theorem says that AC congruent to B D mod n. Here AC equal to 15. 15 congruent to minus 48 mod 7. Minus 48 mod 7. That means 15 plus 48. 15 plus 48, that equal to 70. 70 is, you know that 70 is multiple of 7. Therefore the third property is also satisfied. Next, multiplicative inverse. Definition: given integers n greater than 0, a, b, we say that b is a multiplicative inverse of a modulo n if ab congruent to 1 mod n. AB congruent to 1 mod n. That means if we choose any number 36, you know that 36 equal to 12 into 3. 12 into 3. 36 congruent to 1 mod 5. Okay, 36 divided by 5, then the remainder is 1. 36 congruent to 1 mod 5. 36 means 12 into 3. Here a equal to 12, b equal to 3. Okay, a equal to 12, b equal to 3. Then ab, that means 36 congruent to 1 mod 5. Proposition: given integers n greater than 0 and a, then a has a multiplicative inverse modulo n if and only if a and n are relatively prime. A and n are relatively prime. That means 12 into 3, 36. 12 into 3 congruent to 1 mod 5. 12 into 3 congruent to 1 mod 5. It is clear that 12 and 5, two numbers 12 and 5 that are relatively prime. Also 3 and 5 are relatively prime. After this class we had a new idea about number theory. Thank you.